Hello and welcome to our first notebook, where we get to learn the programming language Python a bit. Python is very simple to use, and it's easy to use it in different ways. In this lecture we mainly use Jupyter notebooks, just as this one, but we'll come later to it how we set one up. For now we just dive into it and accept that we can run Python here. So how can we use Python? The simplest way would be to use it as a pocket calculator. For example, we can start to calculate 3 plus 4. If we execute the cell, we get the familiar result of 7. We can also do other basic operations, such as multiplication or division, so let's try this here. And as we can see, 3 divided by 2 is 1.5. Now try it for yourself and, for example, multiply 25 by 25. Note here the funny hash sign indicates a comment. So anything that is after this is treated as a comment and not executed. So you would remove this one and enter your code here. Now that we're familiar with this, let's make it a bit more complex. Let's say we want to calculate the circumference of a rectangle. And say the long side is 10 centimeters long and the short side is 7 centimeters long. The simplest way to write this would be like 2 times 10 plus 2 times 7, which gives us the correct result of 34. However, that would be fairly inconvenient if you were to look at some more rectangles. It would be nice if you could store the values somewhere, for example in a variable. So let's define a variable. Like the short side is 7 and the long side is 10. Here we notice another feature of Python. We don't need to declare variables, we just use them, or simply we assign a value to a variable. Also, we notice here that there is no output for this cell because we haven't done anything with these variables yet. And another peculiarity of Python is that we don't have to declare the type of the variable. That is inferred by Python itself when we execute the statement. You can use the type statement to indicate and find out what type of variable it is. So in this case it has correctly inferred that we use integer values. This is called dynamic typing, or also duck typing, which means that the types of the variables is determined at runtime when the code is executed. This is one of the fundamental differences to other programming languages such as C++. These use, for example, strong typing, where we need to declare variables and define their type before we can use them. As always, different concepts have different advantages and different advantages. One advantage of dynamic typing is obviously that it's very easy to use. And we can write very flexible code because we don't have to declare and change variables for different types. For example, we could also have written short side equals 7.0 and then we would have used float numbers. The code would have been the same. But in other languages we would have to have different variables for. Also here a best practice before we start using variables. We should try to name the variables so that their name reflects their purpose. We could have written, for example, x equals 7 and y equals 10, but then later on we would have probably forgotten what x and y stand for. We could also have written short as 7 and long as 10. That would have been a bit better. We would have to remember that this is in the context of the rectangle. And if we have many more of these variables, it would be probably a bit confusing to have short, long, and left, right, and so on. So there are many conventions how we can name variables. Some use camel caps. For example, in Java this is more frequent. In Python, most follow the convention of using underscore, as we've done here, short underscore side. At the end of the day, you can choose what you want to do, but it's good to stick to certain conventions everybody else uses as well. Anyway, now back to the problem at hand. We wanted to calculate the circumference, and now we would just store this as a variable cell. So the circumference is 2 times the short times plus 2 times the long side. Again, we also don't have an output now, because we just assign variables, and if we want the output, we use the print statement. So if we do this, print circumference, then we get 34. It would be nice to phrase this as an answer, like like for example you did in primary school, what is the circumference of the rectangle, and then you have to write on a complete sentence. So if you want to do this here, we can say print the circumference is, comma, circumference the variable, which gives us this. However, the print statement is much more powerful. We can place, for example, the value in the middle, or we can find different ways to format the output depending, for example, if we had float values. So the general format is print, some string, then here the variables, dot format, and the variables we want to print. In our simple example here, we can do it like this: circumference is, and then bracket bracket indicates that we use the variable, the first variable that we have, centimeters, and of course we get this statement back. Now as an exercise, do the same thing, but include the length of the short and the long side in the print statement as well. So far, we have only used integer values. Now let's move on and we take real valued variables, so-called floats. Let's repeat the exercise and calculate the circumference of a circle. Print out the result, but now only use two significant digits in the printer. As a hint, first think about which variables you want to use. As a small note, Python itself doesn't know the value of pi, so we'll define it here for the sake of this exercise. We will also not do this later on because we'll import some other libraries that have this defined already, but for now we keep things simple. Here we also use another coding convention. Whenever we need to define such a number or constant or code, we use capitals. Note that there is also no const or other qualifier that indicate that we cannot change this variable. For Python, this is just a variable, and we need to rely on the convention that this is a constant that we must not change. You can also see that my coding environment, Visual Studio Code, has already identified this because I've adhered to this convention. So once you've done this, the circumference of the circle should look like this. If you have, depending on what value you choose for the radius. So in Python, the most basic types you can have is the integer values, which we just encountered with the rectangle, the float values, which we just seen with the square, or strings or booleans, which is true and false. There are two ways we can define strings, either with single quote or double quotes. You can choose which one you want. You can see my string uses single quotes, my other string uses double quotes, and it's the same. However, you cannot mix them. You cannot start a string with a single quote and end with a double quote. You can also convert between these types by placing an int, float, or string before it. For example, we can say the number is 42, what else would the number be, and then print it, and then when we write it out, format it, we can say what is the type, and then convert it, 42, to a float or to a string, and we can see that although we start from an integer value, we convert it to float a string. A final note. Look at the following code. We define short side equals 10, long side equals 15, and go back and calculate our circumference of the rectangle, just as we've done before. But now, the output is 44. That's a bit odd. You would expect it to be 2 times 10 plus 2 times 15, but it's 44. Why is that? Notice that here we've defined a new variable, although we didn't really want to. Remember that before we've done short underscore side, and now we've written short side and forgotten to write the type, the underscore. This tells Python that we want to declare a new variable. This is one of the disadvantages of dynamic typing. If we make a mistake, it's not always easy to spot. So this is why we need a lot of tests, which we will cover later in the lecture.